Okay, the first thing to do in this equation is to square both sides. The radical's already isolated. So it's 5x squared minus 3x minus 41. And you would get 9x squared. Then you get minus 21, which is minus 42x, and you get 49. Then what do you do? Solve for 0, and you can get 4x squared. Let's see, minus 39x, and then you can get plus 90. Now, if you're going to use quadratic formula, you need to identify the big A. In this case, that would be 4. The big B, in this case, would be minus 39. And the big C, and in this case, that would be 90. My issues with that is that the arithmetic is really going to be quite difficult. At least for me it is. So I want to try to factor instead. However, for those students that want to use the quadratic formula, there's the A, there's the B, there's the C, there's the formula, and this is the answer from the formula. But I still want to go through the work of factoring. I like it better. All right, whoops, sorry about that. So it's 0, and I'm going to factor it. And I think it factors pretty nicely, by the way. I'm going to say 4x and x, and I'm going to say 6 and 15. Whatever I say, I want to check it, though. So 4x times x is 4x squared. Then you get minus 24 minus 15, which is minus 39. And minus 15 times minus 6 is plus 90. And the answer is pretty simple to look at. It's 15 quarters, or x is equal to 6. By the way, we're getting the same answer we got over here. One thing that's not being indicated here, which I really want to emphasize, you need to check these. Now, someone says, why do you need to check them? When you square both sides of that equation, you could introduce an extraneous solution. I want to point out that both of these check, though. I mean, they're not bad to check. However, it's more arithmetic, and I don't want to bore you with the detail. But both check out. Where do you check? In the original. I also want to point, looking back over the problem set, anytime I multiply both sides of an equation by a variable expression, you should also be checking that as well. For example, I should really check to make sure this doesn't produce a 0. All right? Let me go through that with you briefly. Someone says where? Here. I want to make sure that doesn't produce 0. And what would you get? 9 times, that would be what? 4/9. Either number would give me 4/9, by the way. And 4 minus 2 is not 0. So this is good. All right. Are there any other equations where I was multiplying both sides by a variable? Yeah, over here. So the answer's over here. That would be bad. If I got 3, I'd have to throw it out because of division by 0. And the other answer that would be bad would be 3/4. I'm not getting those answers, but if I got it, I'd throw them out. All right? Back over here, I'm looking for fractions. And just going back over the set, I know I probably didn't mention that before to you. Over here, x can't be 0. Well, I'm not getting 0. I didn't check them, though. And I know something over here, x can't be 0. Let's look at the answers. I'm not getting 0, so I'm not worried about it. Over here, x can't be 0. I'm not getting 0, so I'm not worried about it. So let me go back to the problem that we're on. And I want to point out that checking, although you may think it's optional, is something that you should consider doing. All right? What does that mean? When you get an answer in the end, plug it into the original equation to see if it makes sense. Now, of course, if something doesn't make sense, you can always reach out to me. Let me remind you about that. All right? My name, Ron Bannon. And if you need to reach me, like you're alarmed by my answers or my work, this is my email address, B as in boy, the @ symbol, NNON.US. All right? Thank you.